Welcome back to Easily Explained, where today we will be talking about the exponential function. So let's get started. Today we will be focusing on the radioactive decay experiment, which is very common with exponential functions. So the idea is that a radioactive substance decays at its half-life. So a half-life of a substance is the amount of time that it takes for that substance to decrease by half. So if we're given a substance and we're given this table, now keep in mind that if we're talking about a 1 second interval all throughout, this would be that the substance has a half-life of 1 second, which is not very realistic, but let's just say hypothetically it did. So initially we start off with 32 grams. Then 1 second, so 1 half-life. So basically divide by 2 and then so on. And you would keep going and dividing by 2. So the next one would be 0.5, 0.25, and all the way down. So one key thing to take from this diagram is that the substance never actually fully decays. It can never actually fully reach zero. It'll keep getting smaller and it'll get to a point where it's very, very, very close to zero, but it will never actually reach zero because nothing divided by 2 is equal to 0. And then when you start to graph these exponential functions, you see a very rapid decrease. But then when it gets to a certain point where it's so low, it's just going to keep going more stable because it's going to decrease less because it's already so small. But it's still never actually going to reach 0. It can never reach 0. It wouldn't continue. It would just go like that, which isn't possible. So writing the domain and range of these type of functions is a little bit different. So in the domain, since this is a real-life experiment about time cannot be negative. So it's just x is greater than or equal to 0 because the time starts from 0 and there is no restriction specified. So it can go all the way 6, 7, 8, 9, 10, and so on. There's no end to time. But for range, it's even more different because you know that it can never actually reach 0. It's just less. Y is just greater than 0. It's not greater than or equal to like it usually was. And the greatest possible value is just the initial value it started with. In this case, it was 32. And this one does have the less than or equal to symbol in particular because it was once equal to 32. So when we talk about an actual function for this situation, we have f of x is equal to, first you write the initial value that you were given, which was 32 in this case, 32, and then half to the power of x, and x is your time, either in seconds or if you're taking it in hours or days or years. So if we were asked to identify any absolute maximum, for example, or an absolute minimum, you actually could not do that. You might be able to do maximum in this case since it's not going to go it's never going to go above 32, but there's no way to identify a possible absolute minimum because it doesn't stop. It keeps going and it'll get smaller and smaller without ever actually reaching 0. So for your practice, you just have 3 separate problems all relating to the scenario that is shown in the very first problem. Pause the video now and complete the practice. Alright, so the answers are now on the screen and let's go over them. A. 128 grams of a radioactive substance exists. Write the function that shows the exponential function in this situation. So we start with our f of x. If you recall from previous videos, that basically just means y, if we were writing a regular equation, is equal to, first you have the amount of grams that you start out with, so 128, and then half to the power of x, where x is the amount of half-lives you could say. So now you want to solve for x is equal to 6. So all you need to do is plug in 6 and then solve. You could also do it with a table or a graph and just divide 128 by 2 6 times, and then you would get 2 grams. So after 6 half-lives, the amount of radioactive substance would be 2 grams. And lastly, does this function have an absolute minimum? If it does, what is it? If it doesn't, why not? So no, it does not have an absolute minimum because it's just going to get smaller and smaller. It's never actually going to reach 0 and doesn't have any stop or any limit. It keeps going until the end of time because it can never actually reach 0.
Congratulations, you are now an expert in exponential functions. We hope this video really helped, and we'll see you guys next time. Bye!